Augmented reality, or AR, is an enhanced version of reality created by the use of technology to overlay digital information on an image of something being viewed through a device, such as a smartphone camera. The most well-known example of augmented reality that comes to mind is probably Pokemon Go. This mobile application allows users to see Pokemon overlaid on top of the physical world through their device's screen. There are many fun augmented reality games available on the App Store today. However, AR has many other potential uses as well. It can be used to view artwork, to measure objects, to order food, to shop for furniture, to visualize data, to view walking directions, and the list goes on. There are also many devices in the market that allow for AR experiences. The first one's obvious. It's probably within arm's reach of you right now, your phone. Thanks to major advances in smartphone cameras and processing power in the past decade, anyone with a smartphone can enjoy augmented reality software. However, there are also some specialized devices available. For example, the Microsoft HoloLens. This wearable device is a headset with transparent lenses, which is different from virtual reality headsets that cover your eyes and prevent you from seeing the physical world. The HoloLens allows you to see holograms projected into your environment, creating a mixed reality effect. The headset is a computer itself with a CPU, the Windows operating system, and a powerful graphics card. The device also contains what Microsoft calls a holographic processing unit, or HPU, to help process all of the sensor data, such as depth sensing and spatial mapping information, which is sensed by projecting infrared light from the device into the physical space. The HoloLens also features voice commands using Microsoft Cortana, hand gestures for input, a gyroscope, an accelerometer, and spatial sound. A second well-known augmented reality device is the Magic Leap 1. This is also a headset, but this device is lighter and smaller than the HoloLens. However, it is connected to a small processing unit called the Light Pack that you can wear by your side. The Light Pack is where everything is processed in the CPU and GPU. The main difference between the Magic Leap 1 and its competitors is that it uses what is called light field technology that projects light rays into your eyes based on data from multiple sensors to create a three-dimensional image that can be focused. This is more realistic since objects that are farther away will be blurry, while objects close to you will be much clearer. The Magic Leap 1 also contains multiple RGB cameras and an infrared projector for depth mapping, as well as an eye tracker to detect which direction your pupils are looking in. There's also a controller with haptic feedback. So how does augmented reality actually work? There are two methods of creating augmented reality experiences: marker-based and marker-less. In marker-based AR, the application uses your device's camera and looks for specified images known as markers, fiducials, or image targets. It works just like scanning a QR code. Typically, images with high contrast, less repetition, and many details are the most recognizable by computers. After the marker is detected, it acts as a point of reference. Knowing the location, orientation, and scale of the marker, the app will determine which virtual objects to display and position them accordingly. Although this technique works rather well, it can be limiting and inconvenient when you don't know ahead of time where digital objects need to be placed. So that's why there's also markerless augmented reality. In markerless AR, applications use complex algorithms to determine the spatial mapping of your environment and orientation of your device to calculate where and how to position virtual objects. Some applications also utilize your device's GPS to place objects at specified latitude and longitude coordinates. The markerless technique allows for more immersive experiences and more flexibility. However, this takes more processing power for the device. Which brings us on to our next topic. What are the shortcomings of augmented reality technology? Currently, augmented reality is rather computationally expensive for devices and takes a lot of battery power. This is due to the device using multiple sensors and resources, which also makes your device feel uncomfortably hot. In fact, many users even disable the augmented reality feature in games like Pokemon Go for this reason. So what's the point in having an augmented reality feature when no one's going to use it because they want to save their battery life? Additionally, you need good lighting for the best results, as AR technology relies on your camera. Otherwise, the device can't detect the marker as easily in marker-based AR. On a related note, researchers are still trying to discover how to accurately estimate the lighting from the physical world and project them onto the virtual objects to create more realistic experiences. Furthermore, some people have concerns regarding privacy, as AR collects a ton of data from the camera feed, which, like any other data, can potentially be hacked. Nonetheless, there are obviously many positives to augmented reality technology. It can be beneficial in a variety of ways, as mentioned earlier. It's especially helpful for visual learners. And of course, it's also a fun experience. Augmented reality is also rather accessible nowadays, as most people have a smartphone compatible with AR software. Of course, specialized devices such as the HoloLens will cost much more. It's also relatively easy to create augmented reality experiences. With a bit of coding skills, almost anyone can develop augmented reality applications. How can you create augmented reality experiences? Apple has released AR-Kit, while Google has developed AR Core. These are software development kits that handle a lot of the calculations behind the scenes to allow developers and creative individuals to easily implement AR into their applications. To use AR-Kit, you'll need a Mac computer with Xcode in the programming language Swift. To use AR Core, you can use any operating system for Android Studio and Java. Additionally, these kits can be integrated with the popular game engines Unity and Unreal. In this case, any text editor and compatible languages will do. Vuforia is also another popular software development kit for augmented reality and is commonly integrated into Unity. All of these kits are free to use and their documentation is rather detailed. You can find them here. If you're interested in developing for particular AR devices, such as the HoloLens or the Magic Leap 1, there are many tutorials for this as well. For instance, Microsoft has released a Mixed Reality Academy full of online tutorials for developing for the HoloLens. They provide videos and snippets of code to help you understand how you can implement them into your own projects. Perhaps using these tools and some programming skills, you can build your own apps and help shape the future of augmented reality. What are other potential uses of this technology? How can we improve the user interface and user experience in augmented reality? How can augmented reality affect our everyday lives? These are questions that researchers and industries are still trying to investigate today. Hopefully in the future, AR will be more energy efficient and be helpful to many communities.